start recording. Yes, you can do different things. So Fusion Compute on that helps you. I'm just want to see my screen quickly and I'll answer you. Okay, so the question was, are you able to use virtual storage when your physical disk is full? So when your physical server disk is full, right, that creates a challenge, okay? But with Fusion Compute, you can manage your storage efficiently. So what they normally do is to handle disk pressure, because you don't want to have disk pressure. There's a way of how you would allocate it. So remember, I mentioned about the thin provisioning, depending on how you provision your disks, your disk. There's also the storage overcommitment. What happens is that it migrates VMs across, right? So it obviously, if you run out of disk space, Fusion Compute allows you to take that VM and move it across, or taking resources from another server, depending on the cluster. Um, but if you have your own virtual disk and you don't have Fusion Compute, you kind of don't have any solutions. So it all depends on the type of technology or services you use. So yes, you can. You can even use external storage in that case. So if you're running out of storage, you would then obviously use the virtual image management system, which obviously provides access through a clustered storage pool in order to use resources. So that's one way. You could either add physical storage if you run out of storage. You could also reclaim unused space, or you could just optimize the VM and say, okay, but the VM don't need so much storage, right? And then you just decrease the storage volume. So that's one way of how you would look at it when you need to, reuse and getting your server disk space back. Okay, I hope that answers your question. But like I said, it's not on all technologies this happens. It's only like in this case, um, you know, um, Fusion Compute. Right, so you can ask more questions if you have any more questions. But that is my answer with regards to that. Now, let's move on. And so we look at Delta Disk, right? So Delta Disk is more, a way of how you look at, creating a snapshot, okay? So a Delta Disk is created using existing parent disk, right? So in this case, you either have a common read-write, or you have the differential read-write. Depending on what's needed, it records only the differential data, and any add-ins you add to that disk, that's relative to the parent disk. So what we mean by that is it takes almost like a selective copy of what's needed, not the full disk. And so a delta disk cannot exist separately from the parent disk. It needs the parent disk. And so if the parent disk is modified, the delta disk is no longer available, right? The data. So if you change the parent disk, that link to the delta disk is no longer available. And so when we look at this, you basically use this delta disk in snapshots when you do snapshots or backup, because it's normally a non-persistent disk also that you can use it for. But that's linked to a clone function of in the system. So it's a clone copy, but it's a link clone. It's a way of how you want to protect the main disk from being modified. And so you create this kind of delta disk on VM disk. So you have a VM, as you can see here, and you have the disk file. This is the normal way of how you would do it. You have your disk file, and it takes the resources from that disk there, right? Or it writes to that disk there. But when you have a delta disk, you have the original disk here, and you have this delta disk file that actually gets a clone copy of the parent. So here's the parent, and there's, let's call it, the child. And so it basically takes properties from the parent. And so you can't use it separately. It needs to belong to the parent disk. And if you modify the parent, so let's say the parent changes, right, then the delta disk, the data is also gone, right? So that's the link between the two when you look at a delta disk, right? So if you look at it from the use case of how we would use a delta disk, you would obviously create a snapshot, keep a backup of the snapshot, and then you'd basically just use it to manage certain things, okay? And so let's say, for instance, we have I'm gonna make examples. So you have let's call it a base.vmdk, right? So that's the base disk, right? And so you have whatever operating system on that base disk, right? Then you would then create call it a delta dot one, let's call it delta one dot vmdk. So you would have these two disks, right? And so this is, obviously the snapshot time when the snapshot was taken, and then any changes after the snapshot gets captured to the delta disk, right? But if you take another snapshot later on, then another delta disk 2.vmdk gets created. Now, what I'm trying to show you is that what I showed you earlier with that VMware that I had actually opened. We use it now. This one. This is Windows 11. And if I had to, let me just go to settings, go to the disk. Can I actually look at the disk? Let me just see. No, I can't. Did I really create a virtual disk? I didn't mean to create one. Okay, let me just go. So all, go to VM disk, go to advanced options. Okay, I can't see anything there. Let me just go to the virtual machine and go to recent. Just open it quickly. So there it is again. Let me just show the Finder. So it is in Finder, and just show the contents. So what you see here, here's your disks, right? So you can see here, these are almost like, you could say this is like a delta disk, because we have the first VM and then we create copies of that. So if I do any write changes, obviously, this is kind of the way of how you look at it, but it's not in most cases what you see in Fusion Compute. I'm just trying to show you with regards to what you would see on a VM disk. You would have these iterations, 1, 2, 3, 4. And that's kind of what you would see with it's still switching off. I don't know what's wrong with this VM. Anyway, that's what you would see with regards to that. So any changes you do after snapshot gets written to the other VM. So if you need to revert back to the first snapshot, you discard maybe delta disk 2. So anything that's written here gets discarded, so it gets removed, and then you revert back to that in case you need to revert back to another snapshot. And then if you need to, you discarded VM disk 2, and you need to save changes, you then merge this delta changes into the base, right? So you merge it into that disk. The system does it itself, and then that becomes, the new OS updates that needs to happen. So again, it's more about, creating this whole isolation performance. If something happens to the VM, you have this delta disk that you can always just go back and look at and recover. All right. So I hope that's the part that and just to cover on the delta disk, so that you need to understand that it works with backup and restoring. It's more about, if you need to go back to certain snapshots, and if there was something wrong with the disk, then you look at that. All right. Now, let's look at Fusion Compute storage virtualization features. So here's the snapshot again that I just spoke about now. So when we look at it, when a snapshot gets created, okay, the delta disk gets created, right? So there's your delta disk, okay. And so when you look at the differential disk, it's also a similar disk, but it's more, a snapshot of that disk. So, it goes with that. So when we look at the snapshot, it gets created. The delta disk file gets created also. And then the delta disk file and the source disk are stored in the same directory, right? So here's your delta disk, and obviously there's your disk data, right? So that's stored in the same directory. Then your source disk then becomes read only. So you're basically creating this disk, which will have read and write, and then the main disk, this one, which is obviously the source in this case here, becomes read only. And then any new data that's written is stored on this file, stored to the disk file. And so when you roll back your snapshot, so here you see here's your disk snapshot done. There's your delta information stored, so there's your delta. And you can see here's your delta also, and that's your differential disk. So if you do a snapshot, like here you have desktop snapshot 2, okay? And so let's say we delete this the snapshot, or we roll back, then whatever was done gets also deleted, right? So that's kind of what happens if the snapshot gets deleted, then the delta disk is also deleted, okay? Or the snapshot is rolled back, the delta disk is also rolled back. And so when you delete a snapshot, the system then integrates the data from the original disk, right? And the deltas in to form a new disk file. So you then becomes a new kind of disk file, almost like this here, depending on if it needs to go back or if it needs to be save changes, right? So depending on that. And then if the snapshot is taken for VM, so virtual machine, all that existing disk on that VM become read only. And then the system creates the delta disk for each existing disk in that data store. So the delta disk is there almost like a failover, to help when you write information that it's not written to the real disk at this stage. It's part of the parent child. So you create many copies of children instead of from one parent. But if the parent changes, all the children disappears, which is weird. But that's kind of what happens, right? Or you merge one child that's probably now the new update into the parent, and that's kind of what happens with the snapshot and delta disks. So when we look at storage live migration, you have the function, obviously that enables disk on VMs to be manually migrated, and other storage units, obviously when VMs are running. And so the live migration is also where you lively migrate this between storage devices and units, even under the virtual storage management. Okay. And so with this function that's enabled in Fusion Compute, the storage resources of that VMs can be dynamically migrated, which means you don't have to switch the device off. Like, we have to switch a server off if you need to migrate certain storages. That makes things easier. It makes, device maintenance much easier. And so here's the technical principles. So with Fusion Compute, you have the original disk data store. With obviously migration didn't start here yet, right? So this is your input output, your disk file, right? So there's your disk file. Now you need to now start, migration, right? Live migration. So from the original disk file, you then create a delta disk, right? So there's a delta disk file now being created, right? And so you have this option of cold migration, which is just, it's basically and live migration for this. So cold is when the system is offline, you're moving, your disks, right? Or you can do live migration, which in this essence, which what we see here. And so cold migration moves the VM disk from one data store to another when the VM is stopped. That's cold migration. When we look at live migration, the VM obviously moves disk from one data store to another without any service interruption. And so you have this kind of write on write redirection on the VM, which then copies it to a differential disk, which you can obviously see here, the whole migration. And then obviously your normal disk, your original disk becomes read only. And then all that blocks in that volume are then read and merge into the disk for the target in. And after all the data changes has been written, it then moves everything back to the virtual disk. So what you see here is that you have your delta disk, there's your original file, you migrate the data, save it to the delta disk file, and again, what happens then after that, that merge together, and then you have a new disk file. This is now if there's no call it rollbacks, right? So that's basically what happens with the delta and the original disk. Again, depending on how you set up your system, you might need this or you might not need it. You could use cold migration if the VMs have stopped and you want to copy, or okay, so I lost. Am I still here? Because it says my connection is poor and it says connecting. Am I still audible? You guys can still see my screen? Don't know what was that. Okay, cool. Okay, I don't know what was that message. Just told me I'm poor. Network is poor. Okay, so that is basically when you look at live migration, right? Again, okay, so again, if you have a VM running, in let's call it, it's attached to a VM and it's in a kind of a clone mode. So it's cloned VMs. You can't migrate that because remember it's cloned, right? So you can't clone a migration. That's the dependency. But if you're running a VM that's, in non-persistence, which is obviously how the Delta disk operates, you need to migrate the disk after stopping the VMs if it's permitted. And obviously, with Huawei, the distributed block storage resources, that cannot be migrated because it's physical raw disk that's available. Okay, so those are just basically just showing you how you can do live migration on VMs using that original disk file. And remember, the disk file refers to the VM decay, the cow files, all those image files that I showed you previously. Just to refresh, I'm referring to these kind of files, these files. Okay, those are the files we're talking about that we're copying across, which is the live migration. Right. So when we look at the raw device mapping. Now this is the raw device mapping, and remember what we said. The raw device mapping is where you can take your VMs to directly access your LUNs, right, on the physical storage subsystems, either through a fiber channel or SCSI. And so this is called the physical device mapping, where your VMs can obviously connect directly to the disk. So with regards to raw device mapping, you bypass the layer of the hypervisor, right? The hypervisor, remembers that layer, as we say, call it the fusion compute. That's your hypervisor layer, right? So you basically are basically here you have your virtual disk that bypass the layer, and in this case you connect directly to the storage, right, or the LUN. And so in this case here you can see bypassing it, connecting straight to the LUNs. Okay, there's no virtual disk or VIMs that's involved here, like in this case. So that's the raw device mapping. The difference between virtual disk and raw device mapping, you directly bypass and you go directly to the hardware. So this again avoids the loss due to virtualization simulation. Remember, this part here is all virtual or virtual simulation, right? And so this, obviously with Fusion Build, as good as it is, it's virtualization. With raw device mapping, you have the VM that directly connects to the hard to the storage, okay, to the storage resources, and that's the raw device mapping. So the advantage of that is that you have the you shorten the input output between different parts and storage devices. You obviously have a better input output performance. And obviously you can see SCSI is being used there, support SCSI. And you have the option to do string provisioning, which you can allocate the disk space. You can also do snapshots, live migration, storage quality of service, even disk backup, because you're basically backing up that file, and so forth. But you can't do the VM part because there's no VM template conversion. Remember, this is not virtual. So any VM template conversion cannot happen on a raw device mapping. So raw device mapping applies to an Oracle database, maybe a cluster file system, or video and image processing services where you have high input output and low latency storage needed, right? Remember, there's latency, and then you obviously have high input output, right? So again, latency, the lower latency is the better sending information, right? So again, you want to have low latency. And so the raw device mapping gives you that ability so the VM can have direct access to the LUN. In most cases, if you have a VM running on your PC, that's kind of like the raw device mapping because you're connecting from that virtual machine straight to your hard disk, right? That's raw device mapping. Now, that's an option also. We have that particular direct access with SCSI. So raw device mapping is using SCSI in this case, to do that. Okay. All right. So when we look at how you develop your network virtualization, so this is now the part of you as an admin that now needs to set up your whole cluster in order to have this whole network virtualization. So again, with compute virtualization, you have to stimulate the network virtualization. And so in a normal traditional data center, your server just runs on an OS, connects to a switch through a physical cable. That we know. And then obviously you implement the data exchange on different hosts, traffic control, security control using the switch. That we know. And after compute virtualization performed, one server is virtualized in multiple virtual hosts, and each virtual host has its own virtual CPU, memory, and network interface card. And so that obviously is essential for virtual hosts to maintain communication, blah, blah, blah. All right, we know that. But this obviously created the demand for virtual switching technology. So, when we talk about virtual switching technology. And so this is where we have distributed virtual switches that's now used. So it's called DVS to configure and manage virtual switches on each host in a unified and simple manner. So all of this that we created now have evolved and obviously now created demand for technology like distributed virtual switches. And the DVS can be configured and managed to monitor your virtual switches on your servers and ensure network configuration consistent when VMs are migrated between services. So this is where we talked about, if you recall, network. I think it was. Let me just go back. Desktop. It was network technology basics. Yeah. So just to recap on that. And so what we said there is that we have, let me just go back to the slides where we spoke about this, which was, it's way at the bottom. It's not that, that is still part of VLANs. It's not the VLAN frame, it's not the assignment. Where's my DVS slides? It's not the gateway. It's not any of that. Just looking for DVS. I think it's under switching. Yeah, it's under switching. That's encapsulation. I don't know, where is it? Okay, maybe it's on another slide that I spoke to you guys about. But I think there's a part where I spoke about this old DVS. Just now can't recall which slide it was. That we spoke about the DVS. But again, it's more about managing your ports. So you have like a distributed virtual switch that are obviously there to manage. So we'll go through that now. And so this is basically where you have the VMs that sits on your servers. As you can see, a server 1, server 2, and then it connects to the switch here. And so this switch then has certain ports. But with this ports, physical port, let's say this is a 24 port switch, right? These 24 ports, you have certain ports that you configure to connect to the server, right? And in the server have distributed virtual switches attached to the VMs that now creates this whole separation. And that's how you would then connect and manage multiple switches on multiple virtual servers. So what you see, you basically look at this, right? So this is called the Linux bridge. And so again, the Linux bridge is a virtual network device that works on layer 2. So this is layer 2, and that functions as a physical switch, right? And so a bridge can bind other Linux network devices and virtualize them as ports. Binding device to a bridge is equivalent to a network cable connected to a terminal. So what you see is you have your host here, which runs Linux, and you have your hardware switch, which is your physical switch, right? Connects to the Ethernet. So this is the Ethernet port. That Ethernet port then creates a virtual bridge, right? So this is the virtual bridge that gets created. And in that virtual bridge then have another, call it a virtual device, which called tap 0 and tap 1, which then connects, to the VMs. And the VMs then connects through that, through the virtual bridge, through the internet. And this is where we have the term called NAT that happens, NAT resolution. So it could have an internal IP of 127, I think 172 dot, let's say 100 or dot 10.1.0. This could be the network, right? And then this could be 172.10.12. No, that's not dot. Let's go to 1. maybe I should have made it 12, and because that's a network. And then you have 172.10.12.2, right? That's the VM. Then it connects here. Now the bridge here would have that network range, right? Would be that network range. And when it gets to the Ethernet might be 192.168. Let's call it dot 1.3, the host. Then the netting basically happens there, so it nets it, and then it's actually seen as, to get access to the internet or whatever needs to access the network. So that's the netting part. But again, this is what happens internally on your Linux, the Linux bridge. It creates that kind of layer. So the bridge basically binds your physical device, your Ethernet 0, to your virtual devices, tab 0 and tab 1. And then that's basically how the layer 2 operates, right? And obviously it deals with MAC addresses because it's layer 2. So when it receives a data packet, it will send the data packet to bridge 0 for forwarding based on the mapping between the MAC addresses and the ports. And that's why we talk about previously where we said distributed virtual switches. So that's basically what we have under Linux bridge. Now, these are just the foundation of how Linux work, right? It has this Linux bridge, and that is basically how you would then operate and send information using the netting part in using that bridge. I'm sure if you look at, there's a application called Mininet, which is, but now that's SDN. But there's other ways of how you can look at this also, just to see how the virtual bridge works. It's also how your VMware and all of those things work. But in this case, in Linux, you have something called the bridge 0, which is the virtual bridge. Now, when we look at the following, we have something called Open vSwitch, right? Open Virtual Switch, which is then a software-based open source virtual Ethernet switch, right? So it's the same as what we just spoke about previously. And so what it does is it supports this multiple standard management of interfaces, such as you have NetFlow, and I just spoke about SDN because it's kind of where we're leading to. It's the same concept. You have NetFlow, you have SFlow, you have Span, you have different type of monitoring tools. But Open OVS supports OpenFlow, right? So in this case here, you have your physical NIC here. So there's your NIC, your network interface card, and you have then that connects to an Open vSwitch, which again, what would you say? It's your distributed virtual switch, right? And that Open vSwitch then connects to your VMs, right? So that's basically how it works. And so again, Open vSwitch has these features: security, quality of service, monitoring, and automated control. So it uses OpenFlow as a protocol. And so what you will see basically is that with regards to OpenFlow, you have a controller that connects with this OpenFlow protocol to your different virtual switches. Okay, and they all then your VMs are connected to this OpenV switch, and that's how they communicate and interact using a physical hardware switch, which in this case it's Alice and Peter that's trying to connect to their VMs, I believe. Right. So those are, the way of how OpenFlow works. So you have this whole thing of packet forwarding that obviously gets forwarded by the switch, and then you have the controller that controls everything, and that's like the router. So it does the data forwarding, basically controlling everything. So again, that is just giving an idea of how the two works and where this open virtual switch comes into play, and the back end process that it uses as part of how it will forward information, from one device to another device based on how many virtual switches you need to have. Right. So if we have to have another virtual switch, we can add it, and then it will just be added, and the controller will be intelligently updated how it needs to control and forward information. Right. Switches only forward information, but then you need to have like a controller that centrally manages all these virtual switches. Now, when we look at this is open virtual switches, which we still talk about the foundation of when we just started with introduction to Linux bridge, and then we moved on to OVS, which is now almost like a SDN, software defined networking concept, right? So that's SDN. But now we're going to look at the following, which now is the DVS, right? And so this is the distributed virtual switch, right? And so the distributed virtual switch acts as a physical switch, right? And then it connects to each host, right? So here you have your normal hardware switch. There's your normal switch, which is here. Connects to your network port. So this is your NICs. And so this is also your NIC. And so that connects to that. Then you have your DVS, which is now the software layer. This distributed virtual switch then acts as that, using OVS, the functionality of that. And so it connects to the VMs through these virtual ports. So these are all seen as virtual ports here. These are all seen as virtual ports. And so that is the connection from the virtual switch. And then the virtual switch then connects to the physical Ethernet adapters, which you see here, the NICs that I just highlighted there. And so that creates this whole VMs to allow the VMs to communicate with each other through the DVS. So in addition, the DVS acts as a single virtual switch between all the hosts, depending on how you migrate it. So your DVS basically could have, and if you look at VLANs, and maybe a VLAN here. So you could have a kind of a VLAN setup here. So that could be VLAN 1, that could be VLAN 2, or it could just be VLAN 200 and VLAN 100, depending on how you define it. And then you would allow a VM maybe to go to that port, but that could be another VLAN. So it all depends on how you define your virtual network layer. But again, these are how you can set up your DVS switch. And so in Fusion Compute, it uses that, right? So again, you have Fusion Compute that uses DVS to provide the independent network planes for the VMs. And so the different ones are isolated like VLANs, which is like on physical switches. And so when you look at your physical servers here, so you have two servers here. It has its physical NIC, right? So there's your physical NIC. You could also bind them, which means you combine the two NICs to work together. So that's called binding. So you bind them together, or you have them isolated like this here. And then you could also, if they bind it, they would all belong, to the same uplink, right? So they will all act as uplink. But again, this is your virtual switch. So this is your DVS, right? Your open source virtual switch. So each virtual switch basically on each server provides for the VMs to access layer 2, right? Because we talked about layer 2 communication here to create the isolation and quality of service. And so the DVS model that we see here allows you to have multiple DVSs to be configured, and then they can serve multiple C nodes in a cluster. So remember when we spoke about the node agent, so the server acts as a node agent, right? So you could have these two working together. So if you have this Windows running here, it then connects to this port group. The Windows is allowed to this port group VLAN 300, and this could be all access. That's right, access switch ports, right? So you could have this configured as access switch ports. And which means that they will only allow VLAN tags through here, depends on the Windows, how it's configured on this virtual NIC. And so that's how it will go through the virtual switch and maybe go through this Windows here. So you could have migration from this server to another server based on the VLAN port ID. So that's important, So you could have multiple nodes in one cluster set up like that. You could create, this virtual switch ports, which is the VSPs, to be configured in a way, and you could have it differently set up, or you could even enable external communications for some VMs, or an uplink link also, depending on how you want to set up this pool, this pool of VLANs. You can do that. So there's many ways of how you can use the DVS, and it all depends on the use case. So you can see there's your virtual switch port. And so this is the same concept that we carried on from the Linux bridge, where you have your physical NIC connects to a bridge, which your virtual switch acts as a bridge, and then the bridge then connects to your virtual NIC, which we said earlier, it's your tap devices in a way. And so that then creates this whole connection, how your VMs connect to the internet, or wherever it needs to go to. And the same concept works with Docker and all these other services and how it interacts to the internet. The same with VMware. So if I have to open up my VMware that doesn't want to stop, I don't know why it's still running. Um, Let me just see if I can. Is this thing still running? Okay, never mind. All right. So for instance, if I go to the network, so I'll just go here now, you will see there's a network adapter, right? And you can see this is my Ethernet, right? How it's connected to. But what happens is as the virtual machine appears as an additional computer on the physical network, means that it's added as additional computer. If I had to change it, which I couldn't now, I could allow it to be, not because this is bridge networking. I could just say it as internet, but currently I set it up as a bridge. And so bridge networking in this case allows me, I can't see much here. Okay, no, there's not much I can see here. But the bridge networking allows me to see what I'm just trying to illustrate to you now in the slides, where you have this bridge, this virtual bridge, that acts, as, this distributed virtual switch. And that allows my VM to access the internet or to connect to that virtual NIC tab. So just to refresh, it starts with the introduction to the Linux bridge, how it works, and that's kind of the whole bridge zero, the Ethernet zero. And that same concept is carried over using the technology of Open vSwitch, which acts as a controller, and OpenFlow as the flow protocol. And then you have the DVS again now, that obviously has this whole Fusion Compute DVS, which is where we're at now. So it just shows you the foundation of where it started off and how it's been customized to be called Fusion Compute DVS, right? And so when we look at the model again, we can see, from the port groups that we created now. So just remember, this is your server here. There's your physical Ethernet ports. There's the uplink port aggregation that gets created, and then you have your virtual switch, right, or your DVS. And so from there, you have your virtual switch ports, which then connects to a port group. So this is what's different now from previously. You now have a port group that's created on Fusion Compute. And so this port group then allows you to set priority like quality of service, priority as also IP MAC functionalities. And then that only then connects to the virtual NIC, which is obviously the tab that I mentioned earlier. And then you obviously has the management part also, which acts as the controller. So when we look at DSVM, it's a distributed virtual switch manager, that administrators can use to define security, quality of services, and how you would set the VM ports attributes. Okay, and so with your port group that you see there, you can have a combination of VMs belonging to certain port groups, maybe with the same network attributes, and you bind those VMs to that particular port group. And based on that, they can that they can either be active standby VMs, or they can be act as load balancing depending on how you set it up. And that's basically how the virtual switching model works in Fusion Compute. Right. When we look at it in a different topology way, you would see that you have your CNA node, your compute node agent here, and you have another one here. So you have two compute node agents, and you have a switch here. So this is your switch, your physical switch. So this is a physical switch. And so this switch here connects to these ports here, which now again is the PC's port, right? The server's port. So there's only one port that's being used here, right? Although we know a server has 4 ports, we're just looking at one here. And so this port again, creates then this virtual, distributed virtual switch. So we have two here. But what you see here is that the way this is configured, it has almost like an overlay. It's a cross. So you have two physical services that's isolated from each other, right? But you have the DVS that's across, right? So you can see your distributed virtual switch, you have a virtual NIC port here that connects to that VM there, and you have one here that connects to that VM. So it means that your VM can actually talk across, the different servers using the DVS configuration. The same with the DVS one here. You have a NIC here that connects to that VM. You have the NIC that connects to that VM, and you have one here, right? However, that's also connected to the other server using VM5 and VM6. And so that is how you can do this live migration and all of that using this feature of Fusion Compute. It's not just about moving VMs across, you need to have the layer 2. So it comes down to what we said in network basics, where we said the OSI layer is important because you're dealing with, encapsulation and de-encapsulation. And because you're dealing with that, you need to know that we have this layer rule. From layer 2, what can happen if there's any blocks, it won't go to layer 3, and vice versa. So you need to have this kind of setup for your VMs as part of the communication. So you would have configured a VLAN 1 and a VLAN 2, using the manager. And then based on that, that's how your VMs would talk to each other. So these two, just want to clear my screen quickly. Where I move my cursor away here now. Um, Let me just erase all in the slide. Let's go green. So when we look at this one and this one and this one and this one belong to VLAN 1. That means that these VMs can, see each other, right? This VM can see them, and as well as this VM, right? So they can ping each other or they can access each other because they're on the same VLAN, right? And when you look at the other ones, you have now this one and this one and this one that can see each other. So that is the whole thing of the VM communication fusion compute, and that allows you then to use these particular NICs that's configured at that VLANs to migrate VMs. So it might not be the same operating system, but you would be able to migrate. Let's say one. This could be a high availability setup. So you have 3 VMs here running, right? And maybe one goes down, you can then migrate that VM across to that host here, to this host here, because of the feature of the VLAN that you added, that because they belong to the same VLAN. Right. So that is mainly why you have this distributed virtual switch. Does that make sense, everyone? Before I move on? So you can move this across based on the VLAN that it belongs to. Because remember what we said, they act as access switches, not trunk. Because remember trunk, you can do VLAN tagging and untag VLANs. But with access switches, you basically just allowed to use that tag that's set on that switch port. And so in this case, there's the access switch. So you basically have this kind of setup. All right. So moving on, we now look at, how does this whole compute network virtualization feature work? So, when we look at the two, so you have something called data plane development kit, which is a collection of libraries and drivers, that's used with this fusion compute. And that's obviously for fast packet processing on this x86 platforms, right? On these particular Intel platforms, okay? And then you have also user mode switching, different types of mode switching, and then you obviously have to use PCI or SRI IO pass through. So when we look at this, you have this part here. We have a physical NIC. You have a virtual switch here, a virtual layer, and then that connects to the NIC. This is your kernel mode OVS. So this provides advanced network features such as IP, MAC address binding, and security group based on network quality of services. Right. The next one here looks at pass through with 2 VMs. So you have 2 VMs, one VM, but 2 network interface cards, virtual network interface cards, that then connects to through Fusion Compute, and that then connects to this call it physical NIC that you see here, and this is the hardware virtualization that's needed by the physical NIC to mount hardware virtual devices to the VMs. And this is obviously for the input output, so that you close to those who provided by the physical NIC. So this is the whole pass through, almost like the GPU pass through that we saw previously. where it enables for that. But now, with regards to the SRIO, which is input output virtual, it enables your PCI cards, right? Your PCI functions to allocate multiple virtual interface to series sources. So, for instance, you might have a NIC that has many ports, right? So you have these ports, right? That's on your physical NIC. And so this could be PCI cards to have more network cards. So you could then obviously allocate that particular setup using pass-through. It's one of the thing that you can do if you don't want to use software emulation, which is this part here. We have a virtual switch. You can go through pass-through, but things that's not supported with it is that hibernation. You can't do online migration, which we did previously. You can't do full migration. You can't do memory snapshots, memory hot add, those kind of things. You can't do that because you're doing pass through. You're going straight through the hardware, all right? So that is that particular mode. And also when we look at the user mode, it's more about configuring memory, right? So you have this kind of processes here, the DPDK, which I said stands for data plane development kit. It's libraries basically that you use. And so again, you need to configure that page memory in order to be configured in the host first. So it's the same thing with a virtual switch, but you have this kind of process libraries, and so you don't need any kernel for forwarding processing. So it also connects in a way straight to the physical NIC, right? Where you need here data channel and flow table still. You don't need that, right? You don't need that part. So that's a difference. And you still connect straight to the network adapter driver or the virtual NIC in most cases, right? So those are three ways of how you would, configure your virtual network in a way. And most cases, this is fine because you just need your virtualization layer, your virtual switch. That's fine. But it all depends on if you need to have faster response from your VM to your hardware. So you would kind of go through a pass-through method, or you could go through this library method where you have, the DP technology is used to accelerate network forwarding and reduce packet copy by using huge space and user mode. So the network forwarding efficiency improved by a maximum of 6 times, and it's greatly improved. So this is a better way. That's only if you need to have, if you have one VM and you need to access the physical NIC faster. Okay, so that's one way of how you look at it. So it's similar to what you saw earlier with hardware assisted virtualization and full virtualization and no virtualization. So when we look at network layer security, and so there is this whole thing of the port group, which you configure as the security, right? And so when we look at the bindings, you can obviously you want to prevent IP or MAC addresses spoofing, which again is called ARP, Address Resolution Protocol, which does that. And maybe the DHCP server spoofing for user VMs. If you want to protect that, you then create layer 2 network security policies. And so with the network layer security policy, you can bind your IP and MAC addresses as part of that group, so only them can be allowed to go through this particular part here, and vice versa. Or you could have DHCP server quarantine if you need to quarantine certain things. Okay, so those are how you could add security policy to it. However, your IP MAC address binds and prevents address spoofing, right? So it's obviously making the MAC address the virtual NIC, and prevents, in a way, that you change the MAC address, right? So you can change the MAC address depending on how you can do it. And so it only allows packets that's from that MAC address and that IP to go through that. So that's kind of the whole dynamic ARP or address resolution protocol. And then with the DHCP server quarantine, you basically it blocks users from enabling a DHCP server on a VM. So only certain VMs which runs as a DHCP server would be able to access a DHCP server. So this could be a DHCP server, that could be maybe DNS, and that could maybe be a web server, depending on what runs on here. And so you would basically allow only that particular server to act, as a server and not others, right? So you could do that kind of setup, or you could have another server on another port and then just block the VM from setting it up self as a DHCP server. So you don't have, there's a whole thing of duplicated IPs being assigned as a DHCP server or IP address. I think they call it, what do we call it? There's a word for it, where you have a duplicate IP because you're trying to access a DAP server. So those are the things that you want to prevent, and so that's why we have this network layer security policy, and that's where the port group comes into play. So again, you also have something called broadcast packet suppression. So again, with that, in a server, or in a desktop cloud scenario, you have packets that get sent across the network, and you get attacked or virus packets that get sent. And so to prevent this, there is a broadcast packet suppression enabled for these virtual switches, right? And so the virtual switch supports suppression of broadcast packets sent from a VM port, and the suppression threshold configuration. So there's a threshold. So it's almost like rate limiting. You're limiting, the VM to send broadcast packets. Let's say you say only 100 packets is being sent, per 1 minute, depending on how you set it up, right? And then that's obviously doing the suppression or the threshold, um, you know. And so you can enable broadcast packet suppression switch on the port group where the VMs are allocated or located, and then you set thresholds to reduce layer 2 bandwidth consumption of broadcast packets. So that's what you can set. And so you as administrator can log in into the system portal to configure packet suppression, and then do for the switch and packet suppression threshold for the port groups of that virtual switch. So those are options that's available for you to use on Fusion Compute, that you can suppress certain packets on layer 2 using the broadcast packet suppression. So now this is just showing you how the security group can be configured. And so if you remember, AWS and Azure and all those cloud service providers, they have this kind of setup. They have security groups. However, security group is rules that you apply to your VMs, right? So again, so users can create security groups based on VM security requirements. And so your set of rules depending on what you configure for each security group, and then the VMs are then added to that particular group. So you can configure the group beforehand. There is a default security group, and then you can set what can that VMs do on that particular group. Okay. You can also add VMs to security group for security isolation, which you would do in most cases, and for access control also in creating VMs. So you might want these VMs to just have access to a certain network, and you can do that based on configuring the security group. And the default one would be maybe just they are all allowed to access each other in most cases. So you would prevent host one maybe to access certain VMs and host two to access certain VMs, depending on the security group that you configure. Because A would be to connect, these VMs, only that VMs there, which would be security group A. You would have security group B, which is this one here for those VMs. And you would have security group C, yeah, for these VMs. And the default ones will fall under this group here. So whatever you configure, so in most cases you configure maybe SSH, SSH, and you configure maybe port 22, and you would maybe allow it or disallow it, or you would configure, let's call it HTTPS. Am I spelling wrong here? HTTPS and maybe 443, which is obviously your server port, or you could block port 80, depending on how you configure your security group. You could even configure maybe if you have a database service, maybe it's MySQL, and so you would configure 336, is it 06, right? Yeah, 3306, and you could allow that port for certain VMs, right? Depending on what you need to use. And so you could configure certain things that you need. You maybe wanted to access a certain IP or not IP, depending on how you configure the group. And that is basically when you configure a certain group. So Just to, I think if you look at your firewall, it acts as a firewall. Your security group is mainly a firewall. So you allow what can go through and what cannot go through. Okay. Now we look at trunk ports. Remember I spoke about access port earlier where I said you can only say one VLAN to allow it through a certain port. Okay. And so here we can look at the trunk port, right? So a trunk port again is where you have a tag VLAN. So you can see here this one doesn't have an ID. So this is a one without VLAN ID. This one here. And this one has VLAN 20. Okay. And so this goes into the port, which is for VLAN 10. What happens here is that you need to configure it either as a trunk port to allow allow VLANs 10 and 20 to pass through. That's what you want to configure. Okay. And that's the trunk port that you want to configure. Otherwise, VLAN 20, if it's just for VLAN 10, VLAN 20 will be dropped and that frame won't go through. It will be blocked here. But if you allow it for pass through, which means you configure it for VLAN 20, it goes through. So in this case, if this was, let's say, host A and host B, in most cases, B won't be able to get through sending packets, but host A will be able to because you've configured it to allow VLANs 10 and 20 to pass through. Right? So those are ways of how you configure, but it depends on if there was a port that you configured here to allow. And the same thing with this side here, if there was a port that you configured. In most cases here, you can see this one is only VLAN 10 port group. Okay. And this is the direction that it's going to send the packets or the frames. So a virtual NIC communicates with a virtual switch through virtual ports, but virtual NIC ports can also be configured as virtual trunk ports to send and receive network data packets with tag or specified VLAN ID. So that's a trunk port. And so now we know that X is just to send stuff. Trunk is basically to use with tag and untag VLANs, which is allowed to it. Otherwise, it will disconnect the network, the VM from the network. But if you add ports to a port group, and obviously in trunk mode in a Linux VM, you can have multiple VLAN tagging devices that can be created to transmit data packets from different VLANs over that one virtual NIC. So that's one way you can also figure it. So when we look at it, this is what happens. So you see there it gets sent. And then what you will see now is that it's sending those tags. So there's VLAN 10 going through. Right, there it goes to VLAN 10. And there you see that one passes through. Right, that's a trunk operation. However, when you see here, there you can see VLAN 10 is going through. And you can see the untag one is going through. And you can see here also the tag VLAN 20 is going through. So that is when you have a trunk port. If you didn't have a trunk port, it would have dropped one of those VLAN tags. VLAN 20 would be definitely dropped, or the one without VLAN ID. All right. And that's basically why you normally configure your virtual switch virtual port, VNIC ports as trunk in most cases. Depending on, so you need to think about your VMs, how you want the VMs to operate, what you want to go through, let it go through. Yeah, so that's the one thing. With regards to network quality of service, you basically have your network quality of service policies that you now have to make use of, allowing for bandwidth configuration and control capabilities. And so you have this thing called bandwidth control for sending and receiving directions to a port group member group. So it depends on the member, and then based on that member, it allows traffic to go through. So this is where you can do traffic shaping by changing requirements. So for instance, let's say you have data, you have video, and you have audio or medium, yeah, audio, right? So you have audio, and so again, you would decide which preferred, is going to be the best, to go through. So you would add your VLANs or your port groups to certain traffic shaping rules. And so if you be a member of the port group for data, you would then be able to forward data much faster through the network. And so okay, so that's mainly where you would use a quality of service. You could also do network port binding as you saw previously in that other slide, where you have two ports, which is physical network ports, which is this one and this one, and you then create a aggregated network port, right? And so this is this whole network binding. So you can configure Fusion Compute to bind network ports on the CNA host. So this could be a CNA1 and this could be CNA2. So these are two hosts, right? And then you could basically bind them all together to have an aggregated network port, or you can do it on one node also, because you might have four network cards, so you could use two of that four and bind them together to create the aggregated network port. And that obviously allows you to improve network reliability, right? Port binding can be configured on common NICs and physical NICs driven by the DPDK. So the DPDK, which we saw earlier, which is um, this one here, the library, it can be configured using that mode. Okay, so that's the one way of how you can also do it. Okay, just going back to my slides. And so again, there you can see the traffic goes through the physical NIC. And so the different binding modes that you get, you have active backup. So you could have an active backup. This could be active, that could be backup, depending on how you want the NIC to work. So your network cable is always in there, right? It's never removed. It's always connected to the switch in many cases. But if that link goes down, you have like a one that goes back up. You could make it a round robin, meaning that you can make it like a load balancer. Um, you can also do IP address port based load balancing. You can do MAC address port based load balancing. You could also do the what you call it the local port based access control ports also that you can configure. So you can see here, there you can see it goes through, and that's basically just to show you the network binding. So you could take a server, and the server would have maybe four NICs, right? And so you could take two of that NICs. So maybe these are the four NICs, and you can bind these two, together. So I think what I'm trying to show you is, if I recall, which I'm going back to, if you look at, I think it's network technology basics we spoke about, or is it now in the server basics? I think it's server basics, yeah. So if you recall from server basics, we spoke about the different ports. It's not that. It was the LOM card. It wasn't server basics. It was one of our slides we covered where we spoke about it. It could be, it must be network technology. So when we look at the network itself and we look at the ports, which I'm just going to try to get now. So not this one. No, that was the VLAN tag. So you can just refresh your mind on that. That was Denison based. Maybe it's cloud based because there's one of these slides that has all of this that I'm talking about. Just okay, okay. Now that's just switch learning reports, not that one. Just trying to see if I can remember still. It's not virtualization. It could be virtualization really because we started off with that. So let's just see. That's not virtualization. That was a short chapter. All right, but I'm just trying to refresh you on that. So unless it's cloud basics. Um, but one of these slides, it's where we spoke about the ports and we said how the VMs operate when you have to share ports. So no, it's not that. It's one of our slides, but just to think about it. It's not virtualization, storage technology, server basics. Yeah, it's one of these slides that we've covered that. But anyway, can't think of it now, but just have to go back and look at those slides. So again, that's where you can bind them together to be aggregated port. And so you either can do a backup or active kind of setup, right? So let's look at cluster resource or cluster management. So Fusion Compute gives you this management part that you see under Fusion Compute. And so you can monitor clusters, that's one thing. And you can query cluster monitoring information, like check the running status of a cluster. You can also configure attributes of the cluster. So you can actually, set up policies like high availability policy. You can set up the memory overcommitment policy, or you can set up when the VM should start. All right, so that's one way also when you can do that policies. And so this is where you go through. You go to home page, resource pool, and cluster. And I'll show you that in the next slide. And then you can also configure resource scheduling policies if you need to, allow compute resources in the cluster to be available for, in the future. So you would basically do dynamic resource scheduling. So that's your DRS, sorry. And then obviously load balancing also, if you need to do that. And so this is where you would go. So if you have Fusion Compute installed, this is the management part that you would see. So you would go to your cluster, and then you would see your control cluster resource, and then you would see how you configure the policies. So you either make it highly available, you make it the resource scheduling, you configure it as a startup. So you could say which VM should start up when the server starts up. And so there's many other things you can configure on this management control, but this is Fusion Compute, the management side that you see. See here, you can add another CNA host. You can add another host here, or you can create a VM on this part here. So this is the management side of Fusion Compute. When we look at host management also again, you can monitor the host. So if you need to monitor the host, there's options to monitor the host and see how they're running. And so you would go to resource pool again under the home page, under host. And that's what you would go to. And so you can also configure host attributes. So for instance, if you need to do a remote configuration, remote into that VM, you could do BMC configuration, or you can set it to maintenance mode. These are all the things you can do. You can maintain also certain ports. So maybe you need to configure binding network ports, or you need to configure the host network ports, or storage ports, how the host needs to store information. You can do that. You can also, associate storage resources with the host to give storage spaces also to which host, and that's under host configuration. So those are the navigation, and so this is what you will see. So you see here now we have two nodes here, two CNA nodes, two compute node agents, and so you can see here under configuration we have the host settings, and this is where you can set certain things, right? So there's the BMC configuration. You can set the page, use page memory features that you saw earlier, and you can also do certain other things also. You can do, there's options for VM. You can enter maintenance mode. So there's many things you can do under the resource pool, but this is where you do the settings and you set up the resources that's available for that. So you can configure the virtual or the BMC IP address to connect remotely. You can put the host in maintenance mode, and you configure local resources also, like, if you need to configure memory optimization, so you can do all of that, even antivirus stuff that you need to configure. And so when you look at the VM lifecycle management, so remember VMs have a life cycle. So a VM might die, you might need to create a new VM, and so forth. So the lifecycle management is you start up the VM, you create the type of VM. So you can either do a bare metal VM from scratch, you can use it from a template, which is, like I said earlier, those files that you can reuse, those VMDK disks or cow files, or you can create a VM using a VM. So you use an existing VM. You can import a VM, or you can convert a template to a VM. Those are the creation types you can do with a VM. So you can create a bare metal, use one from a template, use one from existing VM, import a VM, or convert a VM to a template. Or convert a template to a VM, sorry, yeah. And so your base configuration would be, you then, after that, you've done that mode, you select the data store, where you're going to store it. So is it going to be a SAN? Is it going to be local, or is it going to be NAS, or is it going to be block storage, right? So depending on um, block store, depending on how you're going to use it, you choose any of the type of store. Then you configure your VM. So you say how much CPU, memory, and disk is needed, how many network interface cards, do you need a graphics card, do you need any devices, clock policy, boot firmware, latency, all these other things you can configure. And then after that, you confirm, and that is basically when the VM starts, right? So this is the lifecycle management when you start up a VM, and you have those modes that you can choose when you do the VM. So you can choose any of these modes. So the lifecycle management cloning a VM is also another option. So you can see you can create a VM by cloning existing VMs on Fusion Compute. And that's the live migration feature also. And some parameters of the clone VM can be modified during creation to make it slightly different from the original one. So here you see you can clone a VM, you can migrate, you can convert it to a template, you can do a snapshot, which is the delta disk I spoke about. You can delete it, you can move it, you can remove it from a folder, and you can configure the VM itself, right? So those are things that's available. And so you can see here, this is one CNA node. So again, just to think about the whole setup here, you have one CNA node, which is one server, and you can see all the VMs running on that server. So you have OpenELA running here, Linux. There's a copy of OpenELA there running. You have the VRM, your monitor, your virtual resource manager. So you see this is configured as a VM here. So this is what you now would connect to, to this cluster, right? And you would have these virtual desktops running, which we'll cover later with Fusion Access, because this is your VD desktop. And so again, here you have other VMs also running. Okay, and so you can see the resource usage, the memory usage, the disk usage, the address that's created, and where it belongs to, what cluster it belongs to, and then which is the host. So you can see currently this is one host running all these VMs. If you look at powering off and deleting a VM, you go to power, and you just say stop, right? So that's to stop a VM. If you feel like, okay, you now need to stop the VM, you have it selected, and then you just say power and stop, right? So that is when you want to stop power off and you want to delete, because for you to delete a VM, you probably need to stop it, right? If you need to remove the VM. And then when you look at the storage resource management, so this is now when we look at, giving resources, the storages. So you would use Fusion Compute to take the storage resource from local disk, or if it needs to be independent, to connect through, the optical cables or the network cables, depending on what storage you need, right? So you would start first, you would either use maybe the virtual SAN storage, and you add a port. So you add a service management port. So that's the feature. You add a service management port, and that you'll find under the config here when you set up a new VM. And so you choose adding a service management port, and you obviously add that to the host heartbeat plane, because remember you want to make sure that if something goes wrong on the one node, that there's this heartbeat, for storage. Then you add the storage port. After that, you obviously add the storages to the site. You allocate, associate storages to the host. So maybe the host is, in this case, CNA1. Then you configure the storage mapping. So if you need to do mapping, you configure the mapping. You scan your devices. So after the mapping, you scan to see if it exists and can it be accessed. And then you add your data store, and then you create the disk. So this is the setup of how you would do storage resource management. And so you would go through the step just to create a disk, but you need to make sure if you want to use SAN. If you do direct access, you would obviously configure differently. But again, this is just a process. This is just a reference only that we're showing. It might be differently set up, but this example here is for IP SAN storage. So when you set up IP SAN storage, you would go through this step. If you maybe just connect and just create a disk, you might skip all of this, and you might just create a disk, depending on how your network is set up, or your environment. When we look at network resource management again, this is now where we look at the DVS and the port group and the uplinks, right? So again, here you have your DVS, your distributed virtual switch, which we know is now your two-layer network port group, switch that connects to a port group. And then you have your port group again that you can configure depending on how your VMs need to be connected. And then the uplink is just basically that connects to the DVS to the physical NIC, which then creates the network address translation. Right, so now we're going to look at maintenance management. We're nearly there. So with maintenance management is normally how you want to do management, right? So you want to check how the system is performing. So with maintenance operations, you can check alarms of the system. And so that is normally generated on Fusion Compute on a daily basis, depending on if it needs to be checked. But normal state, it's obviously no alarms. You can check Fusion Compute for the health status to get the health status report. You can check the device running. You can even check the temperature of the device or humidity and dust. If there's any dust, that's picked up, or the quality of the air quality. So those are things of how you can do routine management maintenance. So the alarm management again, depending on how you set it up, you would obviously set it up as critical, major, minor, warning. And so here is just the different severities that you get. You have major, minor, warning. And so these alarms are generated and you can basically handle it based on the severity. So if it's critical, it means that you now need to really look at what's wrong on that VM, right? So you can either see here's the critical, there's no license. So it will tell you that, the system won't run properly because the site license maybe it's not loaded. Major, maybe you're running out of memory, or maybe there's a remote management that you've configured. That's something you need to look at. Or you have network redundancy problems, then users get warnings. But again, these are the alarm management that you would see under Fusion Compute, under monitoring. Then you can also look at the CPU usage. You can monitor, how your CPU performs. You can also look at the KPIs. And so the KPIs is basically just your resources and see how the resources runs on the VMs. And so these are just giving you the key performance indicators. So the key performance indicators shows you how your system is performing, CPU usage, how's the bandwidth usage, how's the local disk usage, memory usage, and even bandwidth outbound usage also. Just to see how's the system performing. Okay. So you can look at that single object, or you can look at that single object with multiple objects. So it depends on the resources you want to monitor. You also have the Fusion Compute account management, and this is normally when you want to add users to the system, right? So you would then use the Fusion Compute to add local users to a domain, and how the user can log into the system after the domain is created. And also you would have Fusion Compute to interconnect with other components depending on how it actually gets set up. And so normally commonly you would log in as admin and the password, and then connect as system administrator. Or if there's a role-based configuration configured, you would either be the role of sysadmin, security admin, or security auditor. Depending on the role that's assigned to that user, that's the preferred way. Yeah, so once the mode is determined, it cannot be changed. So that's the like fixed in stone if you configure a certain role. You can also do backup. So remember the backup policy. The system would back up normally during the day, but you could also do, changing the backup policy. And you can do that basically, if you want to back up the VRM mode, the virtual resource manager mode, because remember it stores information also. So you could do that manually, and you can use that to restore Fusion Compute if any error occurs on the system, because Fusion Compute supports automated and manual backup of critical data. Recovery policy, that's only if something goes wrong. So you can do a rollback on the VRM node if there's any rollbacks is needed. For instance, if the virtual resource manager uses a database, which is a Gauss DB in Fusion Compute, when you restore the data, the restoration of the configuration can be restored and the database data. So that's the recovery policy that you can set. But I think by default that is already set up. But we're just explaining to you basically how you can, modify it if you need to modify it using the recovery policy or backup policy. And lastly, we look at configuration management. So this is just showing what you can do with Fusion Compute. On the configuration side, you can configure domain authentication, how the user would log in to the domain. You can update the license, you can change the system logo, configuring long login timeout. So if the user needs to be logged out 30 minutes after failing to log in, you can do that. You can configure resource scheduling interval. So, when the resources should be scheduled. You can configure SNMP, which is simple network mail protocol. And that's normally when you want to monitor devices using that protocol. And you could, set up a station like that, or you can change the virtual resource manager deployment mode from standalone to active or standby mode. So you can do all that things under system configuration, and you basically just navigate to your system management, and you will see under system configuration, that's where you can do that. You can do tasks and logs, right? Management system configuration, and you can do certain things. So this is where you would navigate to if you need to, do system configuration or add any third-party interconnection. When you look at task management, you can also view the task progress on Visual Compute. So if you installed a VM, you can then go to the task center and the system management and see how the VM is running, started. You can, you can start another, there you can see there's a start that VM, start VM, forcefully stop the VMs, or you can, look at OpenELA and see the high availability VM setup. And you can see there. So these are the tasks that was completed that you can go monitor. And so that ends our session for today. So again, when we look at what's the benefits of VM migration technology, what does it bring to customers? Remember, this is the whole thing of live migration and all the good things. So what we can see is that does it automatically cover services when the VM is faulty? I don't think so, because remember we're looking at VM migration here. So if the VM is faulty, we do know it's going to do this whole migration, depending on the type of setup. But number one, it has load balancing among services. So if something goes wrong, it moves the VM across without any problems. It's also highly reliable on the customer system, and it supports online hardware upgrade. Remember the live migration. So that's that part. But regarding automatically covering services when the VM systems is faulty, I don't think that's correct, because if we obviously said that it covers a VM, yes, but not when a VM system is faulty, because that still talks about Windows, I think, or any operating system. The next one is which of the following memory over commitment technologies are available. So we do know memory sharing. I made example of memory bubble, and I think memory swapping, right? So that is your right answers. That is wrong, because we don't have something called memory simplified. All right. So in summary, we basically learned, the computing part, storage, network virtualization, mostly about DVS. We looked at Fusion Compute and the whole portal, what it looks like, and how you can, manage the portal if you have it in front of you. And so that is basically, the whole Fusion Compute management side that we looked at. And so I think that covers everything for today. If I look at the next ones that we'll look at, which we're not going to go through tomorrow, we'll do that, I think Wednesday's fine. But we've covered virtualization management platform and usage. So the next one is Fusion Access, and that is where we look at what is Fusion Access and how you access Fusion Access to get to the Huawei VRM. All right, so that is that part, and then we'll just go into Fusion Access, and lastly we'll look at cloud computing trends. So these are more or less short slides, I believe. So hopefully Wednesday we can cover two. We can maybe cover Wednesday all the Fusion accesses, and then just finish off with cloud computing training. So we should be done with theory this week. Gives you more time for revision also. Right. So let me just stop the recording.